Today we're going to continue to look at polar coordinates, but today we're going to actually go the other direction. We're going to go from rectangular coordinates to polar. So yesterday we spent some time looking at the two formulas up above. We know that x is equal to r cosine theta and y is equal to r sine theta. So I was able to give you a polar coordinate and you are able to find the rectangular or the xy coordinates. Okay, so like I said, we are going to go the opposite direction today. And we're going to talk about how to come up with these these formulas on the side. Okay, so yesterday we talked about this little picture down here where we know that x is the x coordinate and then this is y, and we also know the r and the theta. So we know these two formulas up above already. We know that x is equal to r cosine theta and y is equal to r sine theta. But what happens if I know x and y? Okay, so how could I find r if I know x and y? Well, since this is a right triangle, we can use Pythagorean theorem. X squared plus y squared is equal to the r squared. So that gives us our first link between if I know x and y, how can I find r? Or if I know rectangular, how can I find those polar coordinates? All right, I would square root both sides, but don't forget when we square root both sides, we get that plus or minus in front. So realistically, this is just solving that equation for r. I would just root both sides and I get plus or minus square root of whatever x squared plus y squared is. All right, so theta is a little bit of a different story. If I know y and x, so again, I'm going to ignore the fact in this case that this is r. If I know y and x, how can I find theta? Well, I know y is the opposite side and x is the adjacent side. So that lets me figure out that tangent of theta is equal to y over x, right? Opposite over adjacent. So if I were trying to solve for theta, if I wanted to get that theta all by itself, I would have to do the inverse tangent of both sides. So I know theta is equal to the inverse tangent of y over x. So we're trying to figure out what angle gives us a tangent value of y over x. So since we're solving for the angle, that's where we use that inverse tangent or that second tangent button on our calculators. All right, so one of the things that we have to be really careful with is when we convert from rectangular to polar, or even from polar to rectangular like we did yesterday, you always want to just sketch your graph. You want to make sure that that point is ending up where we think it's going to. So today first example, we're going to go from rectangular to polar, and we're going to do that polar coordinate in radians. Realistically, we could do it in degrees if we wanted, but we're going to do it in radians. So the xy point that we're looking at is -3, -3. So if I were to graph that point, I know I go back 3 and down 3. So I know my point has to end up in quadrant 3. All right, so let's find r first. That's the easy one. I know that r squared is equal to x squared plus y squared. So to find r, I have to do -3 squared, which is 9, plus -3 squared, which is 9. So I know r squared is 18, and if I root both sides, I get r equals plus or minus. We got to break down that square root. So that would break down into 9 and 2. So that would be 3 root 2. So I know my r values can either be positive 3 root 2 or negative 3 root 2. All right, if I want to find theta, I know that tangent of theta is y over x. So my y value, I know that tangent of theta is equal to y, which is -3 over -3, or basically tangent of theta has to be positive 1. Okay, so think about where tangent is positive 1 on our unit circle. I know that tangent is positive 1 at pi over 4, right? I know it's also positive at 5 pi over 4. If I wanted to keep going, if I did a full circle plus pi over 4 again, that would be at 9 pi over 4. And I could keep going. This list would go on and on depending upon how many times I want to go around that circle. All right, but we're going to find two polar points. And again, remember those polar points have to be r comma theta that will get us to this point up here in quadrant 3. All right, so what we have to do is we have to make sure that we pair the correct root 2 over, or 3 root 2 over 3 root 2 positive, or the -3 root 2 with the angle that will give us that same point. Remember, we want to get back to that point that's in quadrant 3. All right, so if my angle was pi over 4, so if my theta of my point was pi over 4, I know that pi over 4 is over here in quadrant 1. So hopefully you realize that I would have to go in that negative direction, so that has to be paired with negative 3 root 2. All right, because I would rotate to pi over 4, and then I'd go in the opposite direction on that opposite ray, and I'd go out negative 3 root 2. All right, if I was going the other way and if I was at 5 pi over 4, that's down in quadrant 3. So pi over 4 is down here. So then that means I need the positive r value, that 3 root 2, to be paired with 5 pi over 4. Okay, now if 9 pi over 4 would be in quadrant 1. So I would have to pair negative 3 root 2 with that one. Okay, so that is those are two different polar points that end up in the same location as my rectangular point. All right, let's do the same thing with this next point. So we're going to find two polar coordinates, one with a positive r and one with a negative r, of a point who has rectangular coordinates negative 2.3 comma 0.1. All right, so again, just real quick, if I'm going negative 2.3 and up 0.1, negative 2.3 up 0.1, that would be somewhere in, that didn't work so well, somewhere in quadrant 2. All right, so again, let's find r first. I know that r squared is equal to x squared plus y squared. So r squared has to be negative 2.3 squared plus 0.1 squared. Again, I'm going to go to my calculator there, type that in, take the square root of both sides. So I know that r has to be approximately equal to, because it's not a perfect square, or it's not a perfect square root, plus or minus 2.3. So I know those are my r values. So one of my points is going to have a positive 2.3, and my other point has to have an r value of negative 2.3. And remember, it always goes r comma theta, so the r value has to go first. All right, so now let's talk about the angles. I know that tangent of theta has to be y over x. So in this case, tangent of theta is going to be equal to 0.1, the y value, over 2.3. Because remember, this is x and this is y. This is not a unit circle value, so this is something that I'm going to have to use my calculator for. And remember, anytime we're looking for the angle to find theta, we have to do inverse tangent of 0.1 over 2.3. All right, so when we plug that into our calculator, that gives us a theta value of 0.04. Now, one of the things we have to be careful with is tangent's actually positive in two different places. Tangent's positive in quadrant 1, and it's, I'm sorry, that was a negative value. That's negative 2.3 there. So tangent is actually negative in two quadrants as well. It's negative, and oops, I made a mistake there because I didn't use the negative sign. This should be negative 0.04, not positive 0.04. So hopefully you caught that. So that gives me an angle that is negative in quadrant 4, because that's one place where tangent is negative. Tangent's also negative in quadrant 2. So I have to rotate back from pi, since I'm in radians, 0.04 radians back from there. So what would those angle measures be? This first angle would be negative 0.04, like we said. If I take pi and subtract 0.04, this gives me a positive angle of 3.10. All right, so that gives me a negative angle and that gives me a positive angle, and that's okay. I'm just looking for two angles that happen to have, or that get me to those polar coordinates. All right, so let's think about where that point exists. Remember, that point is somewhere in quadrant 2. So if I rotate into quadrant 2 at that 3.10, I know that my r value has to be positive. So my angle would be 3.10, and we said our r value has to be positive. In this case, it's going to be positive 2.3. Okay, so again, remember, if you rotate to that ray and go out on that ray, it's going to go out positive 2.3 units, and that would end up in quadrant 2. If we're using the angle down in quadrant 4, we know that we want to go negative, right? Our R value has to be negative 2.3 because we want to go in that opposite ray or on that opposite ray in that opposite direction. So when the angle is negative 0.04, my R value has to be negative so that I end up in quadrant 2. So we do have to make sure that we plot those points and that we match those points together. All right, so let's talk about polar and rectangular equations. Okay, so not only can we take polar points and rectangular points and convert back and forth, but we can also take polar and rectangular equations and convert back and forth. To write an equation in polar form, we have to get rid of all of the x's and the y's, and you can only have r's and thetas. Okay, to simplify, we want the r's and thetas on one side of the equation. So let's take a look at this first one. We want to write the following rectangular equations in polar form. So we want to get rid of the x's and the y's, and we want only r's. So we need to get rid of this y. So the first thing we need to do to get rid of that y is we need to remember those two equations. We know that y equals r times sine of theta, and we know that x is equal to r times cosine of theta. Those were the formulas from yesterday. All right, so if I take out that y, I can replace that y with r sine of theta, and that's equal to negative 3. So that one was actually pretty easy. We just took that y, out, and we plugged in r sine theta. Okay, remember there are a couple more formulas too. We know that x squared plus y squared equals r squared. And we also know that tangent of theta equals y over x. So those are the formulas that we might use to go back and forth between polar and rectangular. So if I look at letter B is actually kind of nice because I see an x squared plus y squared right there. Well, I know that x squared plus y squared is equal to r squared, so I can just take out that x squared plus y squared. I can plug in r squared, and that's equal to 4. So I didn't need any thetas here. I know that r squared is equal to plus or minus, or is equal to 4. And if we want to go one step further, we could actually root both sides and solve for r. So we could say r equals plus or minus 2. Okay, technically I would accept either of those equations. So either the r squared equals 4 because you did get rid of the x's and the y's and you got r's, or you could square root both sides and solve for r, but don't forget that plus or minus. All right, last one. Again, we've got to get rid of the x and we've got to get rid of the y. So all we're going to do here is we're going to plug in using those y equals r sine theta and x equals r cosine theta formulas. So here I get 3, and instead of x, I'm going to write r cosine theta. Instead of y, I'm going to write r sine theta, but don't forget I've got to square that, and that's going to be equal to 2. Okay, so again, remember we want to get the r's and thetas on one side of the equation. So in this case, I just need to simplify here. So that gives me 3 times r cosine theta times, if I square it, don't forget I've got to square both the r and the sine theta. So that gives me r squared times sine squared of theta equals 2. If I simplify that, notice that we have an r here times an r squared over there. So that gives me 3r to the third. And then I've got a cosine theta and a sine squared theta, and that equals 2. So I've got the r's and the thetas on one side. I've got the 2 on the other side. So that would be the same equation in polar form. Okay, some of the equations look nice, like the first two kind of look nice. That third one is a little ugly. All right, so let's go the other way. Let's go from polar to rectangular. Okay, so again, we've got those same 4 equations, that x squared plus y squared equals r squared. We've got tangent of theta equals y over x, and we know that x is r cosine theta and y is r sine theta. Okay, so we're going to use those same 4 equations that we just talked about. But to change polar equations to rectangular is a little bit trickier. All right, so common methods used are either to square both sides or multiply both sides by r. Okay, just like with r's and thetas, we do want to get the x and the y on one side of the equation. And if we can, we want to complete the square. So we'll see what that looks like in a second. All right, so again, we can either square both sides or we can multiply both sides by r. All right, so don't forget that x squared plus y squared equals r squared. We've got tangent of theta equals y over r. We know that x equals r cosine of theta, and we know y equals r sine of theta. Those are our 4 formulas. All right, so if we take a look at r equals 5, okay, so again, we could either square both sides or we could multiply both sides by r. So if I were to go ahead and square both sides, that gives me r squared equals 25. And I know that r squared is the same as x squared plus y squared, so I can get rid of that r. I can get rid of that r squared, not just the r, and I can write x squared plus y squared, because that's going in place of r squared, is equal to 25. Okay, so again, I got rid of the r's. I got x's and y's only, and x's and y's on one side of the equation. All right, so this next one, I could either square both sides or I could multiply both sides by r. So one of the things here is if I were to square both sides, I get r squared, and I would have to FOIL out that cosine plus 2. Okay, so that really wouldn't help me because I don't have an r cosine theta, I don't have an r sine theta, and I don't have an r, well, I do have the r squared, so that would help a little bit there. Okay, but let's see what happens if I multiply both sides by r. Okay, so if I multiply both sides by r, that gives me r squared, which I can get rid of. If I distribute here, that gives me an r cosine theta, which I can get rid of, and then plus 2r. And if I go ahead and if I square root both sides there, I can go ahead and simplify, or I can get rid of that r as well. So in this situation, multiplying both sides by r is going to be our better choice. Okay, so when I do that, I can substitute r squared for x squared plus y squared. That equals r cosine theta is just x plus 2. Remember, when I square root both sides, don't forget I do get plus or minus the square root of x squared plus y squared. Okay, now that doesn't look very nice. However, remember our goal is to get rid of all of the r's and the thetas and only have x's and y's as our variables, which in this case I did. All right, so we do like to get the x's and y's on one side, so I could move both of those to the other side. So I get x squared plus y squared minus x, and then minus 2 times plus or minus the square root of x squared plus y squared, and that's equal to 0. Again, that is a pretty ugly equation. There is really not much we can do with that. I know I did mention completing the square if possible, but this is a situation where I would not complete the square. All right, let's take a look at this one. So again, my options are to square both sides or to multiply both sides by r. Okay, so again, if I squared both sides, I would have to multiply out sine minus cosine of theta times itself. That really wouldn't help me because it doesn't give me any r sine thetas or any r cosine thetas. Okay, so hopefully you see that that's not the route to go. So what I want to do is I want to multiply both sides by r. Okay, that gives me r squared. And then when I distribute, that gives me an r sine theta minus r cosine theta. So hopefully you see those formulas jumping out at you there. I know that r squared is x squared plus y squared. I know that r sine theta is y, and then r cosine theta is just x. Okay, so this would be a situation where I want to get everything on one side and complete the square. So if I take the y in the negative x and move it over, that gives me x squared plus x. Remember, completing the square, we want to put those x's together. Then I get a y squared and minus y. I'm going to leave a little space there, and that's equal to 0. Okay, so don't forget when we complete the square, we've got to add what we add to the left side to the right side as well. So hopefully you remember completing the square. Remember that b term is 1. I'm going to take that b term, I'm going to cut it in half, and I'm going to square it. And that's what we add, in this case, on that little squiggly. If you look over here, now my b value is -1, so I want to take -1, cut it in half, and square it. That's still going to be 1/4, so I'm going to add that 1/4 on that little squiggly. But don't forget what I add on the left side, I've got to add on the right side, so I've got to add a 1/4 from the x's, and I also have to add a 1/4 from the y's. All right, so what does that do? What does that give us? Let's make it look a little bit nicer. We need to factor right here. Okay, so what are my factors of 1/4 that add up to 1? Well, remember when we completed the square, it's always going to be that what you got when you took b and cut it in half. So when I factor this one, it's going to be x plus 1/2 squared. All right, so I'm going to get rid of that just so that it doesn't take up enough room or take up so much room. Now I've got to factor the y's. So don't forget, like I just mentioned before, whatever goes inside the parentheses is that -1 cut in half. So this time when I factor the y's, I get y minus 1/2 squared. Okay, and that's equal to 1/4 and 1/4, which is 2/4 or 1/2, and there is my equation. Okay, so hopefully remember completing the square. Hopefully that came back fairly quickly. And in this case, it wasn't too bad. It's obviously nicer to complete the square when you have even numbers, but in this case, we had a 1 and a -1. All right, let's take a look at letter B. Letter B says r secant theta. Well, I don't know any formulas with secant in it, so I'm going to go ahead and get rid of that secant. And that secant is really just 1 over cosine theta, and that's equal to 6. All right, I don't want that fraction there, so that technically gives me r over cosine theta equals 6. I can do one of two things. I can either multiply both sides by cosine theta, or I could put that 6 over 1 and cross multiply, and that gives me to r equals 6 cosine theta. Okay, I'm still not quite there yet because I have two options. I can either square both sides or multiply both sides by r. So hopefully you see here that multiplying both sides by r is the better way to go, because when I multiply the right side, that's going to give me 6 r cosine of theta, and r times r is r squared. And now I can make some of those substitutions. So I'm going to go up here. I know that r squared is x squared plus y squared, and I know that 6 times r cosine theta, I know that r cosine theta is x, so that's just 6x. Okay, so again, we want to get everything on one side, and we want to complete the square. So that gives me x squared minus 6x, and again, I'm going to leave a little blank, plus y squared equals 0. I don't have to complete the square with the y squared because there was no just plain old y. So I'm only going to have to add what I put in to the x's to the other side. So remember, we take that -6, we cut it in half, and we square it. So that's -3 cut in half. I'm sorry, -6 cut in half is -3, squared is 9. So I'm going to have to add 9 to both sides. Okay, remember when I go to factor it, it's going to be x and then minus, in this case, whatever I get when I cut -6 in half. -6 cut in half was -3, so it's going to be x minus 3 squared plus y squared equals 9. Okay, and there is the equation in polar form. I'm sorry, in rectangular form. So again, you have options of either squaring both sides or multiplying both sides by r. I don't know that there's necessarily a rule on when to use which one. But if squaring both sides doesn't help you, go back and multiply both sides by r. And that's all we got for today.